I would like to welcome everyone to AJL at 80, a symposium to honor the 80th birthday of our colleague and friend Tony Leggett, who's sitting right here so we can embarrass him throughout the day. I am Dale Van Harlingen, and I have the great honor and pleasure of being the head of the Department of Physics at the University of Illinois. There are many reasons why it's great to be in physics at Illinois. One is that we have a lot of great faculty and staff who motivate and inspire us to do amazing things every day in research and education. But another is that we have in our department a very unique interactiveness and camaraderie among our people that drives us to want to celebrate who we are and what we do as often as we possibly can and with as much energy as we possibly can. So it is hard to think of anyone we would rather celebrate than Tony, one of our most famous and our most impactful and our most beloved faculty members at Illinois, and for all of us, one of the most impactful scientists of our generation. And it is hard to think of any way to better celebrate him by bringing together all of you from different parts of the world and from different generations to share in honoring him and his remarkable accomplishments. We are delighted that you have all come to Urbana for this very happy occasion. We are very proud of our department. We are pleased to show it off to many of you who have not visited our campus for a long time. And I know there's many of you out here I've seen today who haven't been back, and we're going to hope have a chance to walk around and see our building and what we've done here. So when we started planning this symposium, really more than a year ago, we asked Tony how we could best honor him. And knowing Tony, I don't think we were at all surprised by his answer. He first said he didn't want this to be about him. He also said he didn't want it to be about the past and about what he has contributed to science in his career, which is, of course, an amazing lot of things. Tony wanted a symposium that looked to the future, a forward-looking lineup of speakers and talks in areas in which he has made contributions and or finds to be exciting and important. So, Tony, we will honor that request. Well, sort of, but not completely. We have indeed put together what I think is going to be an exciting and for the most part forward-looking program. As you can guess, it was not easy to choose speakers and topics. Tony has so many interests, he has impacted so many areas, he has so many friends in so many places. So we had to make a lot of difficult choices, but I think we ended up with a program that you might best describe as physics Tony likes by people Tony likes. And I think there's no better kind of symposium, I think, to have. And I should mention that we'll end the symposium by compiling a list of unsolved problems so that Tony knows what to work on in the next 10 years of his career. You're not stopping, Tony, not as long as I'm here. And that will be our present to you at the end of this conference. So I might take this opportunity to explain this. This is a Tangle. It's a toy that I've played with for many years. It's kind of a precursor to the fidget spinner, if any of you have those in your pocket. We chose this as a gift to give out to people as a symbol of an unsolved problem. Because no matter how you twist this thing, you can never quite get it to go into an ordered state. It gets pretty close, but there's always something wrong. So it kind of reminds me of high-temperature superconductivity, which also sort of has that same property. So, however, the forward-looking agenda that Tony wanted to have competes a little bit with our strong Urbana desire to celebrate people and events and to party. So we're going to do that too. We think you cannot understand Tony without talking a little bit about the past, and there are too many good memories and too many stories that all of us have had over the years to not share them. So over the next 2 days, as we look ahead to the future, we're also going to look back to honor Tony's remarkable career and the global impact he has had on science and his fellow scientists. So as we start this symposium, before we share Tony with the rest of the world, we're going to take the liberty in this first session to be a little bit selfish, take home court advantage of being in Urbana, and talk a little bit about what it has meant to us in Urbana to have Tony on our faculty. So I've asked a number of people who are or have been at Illinois to share their experiences with Tony and describe the impact that he has had on them in physics and beyond. So we're going to start with some people who are not actually physicists. Well, they really are. They're both physicists, right, I think. And first, let me start by introducing the director of the Center for Advanced Study at the University of Illinois at Urbana-Champaign, and currently the interim dean of the College of Engineering, Tamer Bassar.
Thank you, Dale. It's good morning, everyone, and thanks for coming and helping us commemorate this 80th birthday of one of the most outstanding scientists of our time, yet one of the most humble and amazing people as well. It's fitting that we mark this milestone with such a symposium as this. As Dale indicated, I'm wearing two hats today. One as director of the Center for Advanced Study, where Tony has been a member since 1985. And the second as interim dean of the College of Engineering, where he has been a physics faculty, John D. and Catherine T. MacArthur Professor of Physics since 1983. The gathering here today, continuing through tomorrow, is a true testament to Tony Leggett's remarkable scholarly accomplishments and his generosity of time and expertise with colleagues and students alike. It's a true testament to what he has meant to physics, and particularly the field of low temperature and condensed matter physics. He claimed the 9th Simon Memorial Prize of the British Institute of Physics in 1991. This is a very selective list, as you can imagine. The Wolf Foundation Prize for Research on Condensed Forms of Matter in 2002 and 2003, and of course the most notable, the Nobel Prize in Physics for pioneering contributions to the theory of superconductors and superfluids in 2003. He has shaped the theoretical understanding of normal and superfluid helium liquids and other strongly coupled superfluids. But his career, and in fact now I'm part of the program where we talk about the past, and there will be plenty of opportunities for the future. His career nearly took a completely different turn. As he notes in his autobiography, written at the time of his Nobel Prize, it was a common practice in England at the time for schools to channel students as young as ages 13 to 15 into either a track of classics and modern languages or one of math and science. That would ultimately determine what degree you might pursue in college. Ultimately, Tony pursued the former, that is the classics and modern languages, resulting in a degree focused on the classical languages and literature, philosophy, and Greco-Roman history. He credits that degree for helping, and I quote, shape the way at which I look at the world, and in particular at the problems of physics. Having little interest in the British civil service or pursuing a doctorate of philosophy, and because he saw the need for the West to grow its knowledge of science and technology following the Soviet Union's successful Sputnik launch, he decided to pursue a second undergraduate degree in physics. And then the rest, as they say, is history. He first arrived on this campus in 1964 as a postdoctoral researcher to study under the likes of David Pines, John Bardeen, Gordon Baim, who is on the program, and Leo Kadanov, sparking his interest in the superfluid phase of liquid. After spending time in both Japan and his home country of England, he returned to Urbana-Champaign in 1983 as MacArthur Chair. Of course, what distinguishes Tony is not just his incredible influence on science, but his equally incredible influence on people. His enthusiasm for teaching fundamental physics courses to literally tens of thousands of students here at Illinois has never wavered. The lineage of students and their subsequent successes over the past 35 years is most impressive. And of course, his wit and his ability to hold a room are still alive today as ever. He has assuredly lived by his motto, and I quote, "Rush in where angels fear to tread." Let me share with you a little bit of history now as regards Tony's involvement with the Center for Advanced Study. As I indicated earlier, he was elected in 1985 to the center, and he was the only faculty member elected that year. So I went back to the archives, to our archives at the center. Election to the center actually follows a very stringent review process following nomination by nominee's department head. But as you can imagine, his was an extremely easy case to make. In support of his nomination, the physics department head at the time included a strong letter of endorsement from John Bardeen, which concluded, and I quote, "It's considered likely that Leggett will someday receive a Nobel Prize." And so John Bardeen was an extremely accurate forecaster and predictor, as you can see. Now, further in the, and several letters of reference were collected at the time, further in the words of one evaluator, and again I quote, "In my view, Tony Leggett is in many ways quite similar to John Bardeen, both in his wisdom, his taste for choosing important problems, and his ability to be right essentially all the time." Tony's contributions to the center for the past 33 years have been enormous. He's a truly valuable colleague at the center, as Dale indicated. His contributions to physics are also unmatched, and both to the community as well as teaching and research here. He faithfully does much more than an average center professor delivers in terms of our annual rankings for associates and fellows in that competition, attending meetings to discuss items such as the center policy, campus issues, state and future of the center, or simply enjoy an informal moment with colleagues from across campus at the annual roundtable and reception. So Tony, on behalf of the College of Engineering and the Center for Advanced Study at the University of Illinois, I want to thank you on what you have meant to us all, and congratulate you once again on what you have meant to the world of physics, and send our best wishes on your 80th birth year.
It is now my great pleasure to introduce a very great personal friend of mine and a great supporter of physics for many, many years on this campus. Now the Vice Chancellor for Academic Affairs and the Provost of the University of Illinois, Andreas Kangaleras.
Good morning and welcome to Urbana-Champaign, what I call the most exciting community in the world. Thanks to the physics department at Illinois. I always tell people that what physicists do every day is they inspire the world about the world and the value it holds for everyone. And I will tell you, when it comes to an image that describes this, I cannot help but always bring in my mind Tony in the market in Urbana talking to a young girl about physics, most likely superconductivity, and that young girl having this expression of awe and excitement about this. This is what it is all about. I'll tell you, this is what physics means to the world, and oftentimes when people ask me, what do physicists do beyond inspiring the world about the world? I tell them, what they do is inspiring the world to care about the world. Tony is one of the best minds that I have encountered. About a month ago, we were having dinner to welcome the new Chinese Year, and we talked about many things. One of the things we touched upon was what is happening in the world today. And he's very careful in what he says, but it was a very intriguing conversation. We are delighted to have you here. I can tell you on behalf of the University of Illinois campus and the community, thank you for being part of this celebration. You know, it was, I think, yes, I know, it was Thucydides who, inspired by Pericles, another hero of mine, said, and I paraphrase here, distinguished, brilliant men are global citizens. And that's what Tony is. He is a global citizen. But at the same time, he calls Urbana-Champaign home. And for that, we are most thankful. Tony, congratulations on your birthday. On behalf of the entire campus and the community, many happy returns and many more discoveries. Thank you.
So the picture that Andreas was referring to is actually on the back of the cover here. It shows Tony with the young woman. And if I am not mistaken, you were talking about the moon. Is that correct? Not superconductivity. And you probably misinformed her. Okay, great. So anyway, it's a great story, though. And thank you, Andreas, for your support over the years and for the kind things you say about physics, which we always appreciate. So now I would like to talk about what Tony really does, which is theory. And I'm not going to talk about that. I'm going to have some people talk about that. Tony is a great theoretical physicist. I think one of the great minds, as Andreas said, of our time. And so we have lined up a couple of people who worked with Tony over the years, and I think no one has worked with him probably quite as long and in as many areas and has the same versatility in fields as Gordon Boehm. So Gordon, please.
What a wonderful room full of people. Many, many old friends. Welcome to Urbana. It's like being in the old days here with Tony. So thank you all for coming. Looking around the room, I realize I'm probably the person here who's known Tony the longest. Is any competition? Ralph and Lizzie go lost. Ralph Sims, yeah. So we go back to 1964 when Tony first came here as a postdoc. And we talked a lot of physics, and at the time he was worrying about developing Fermi liquid theory for electrons in superconductors, if I recall. And it's always been fun to talk physics with him. But Tony has many hidden talents, which I didn't realize at the time. And we first began to see this when, in the summer of 1967, we were at the Aspen Center for Physics together. And at that time, the Aspen Center for Physics was being run by the Aspen Institute, which was basically University of Chicago Humanities operation in good part. But the Institute no longer wanted to support the center. And so they arranged a separation. And to do this in proper style, they decided there would be a debate between physicists and humanitarians from the Institute. And we were presented with two topics. One was Billy Budd by Herman Melville, and the other was Thucydides, here he is again, second time today, so Thucydides' funeral oration. And so we settled on the funeral oration, and our representative naturally was Tony. Tony had the unique property of being the only person who had read Thucydides in the original classical Greek. So needless to say, he won the debate hands over, but we lost the war. Anyhow, so the Physics Center has been going on well by itself. Funny story, about 10 years ago, I was in Philadelphia listening to a talk by Sir Hugh Lloyd-Jones, a very famous classicist who was talking about how the Greek and Roman gods had so much fun. And so afterwards, I realized he must have known Tony. So I went up to him and asked him about Tony. He replied immediately, "Oh, Leggett, clever chap. I wonder what ever became of him." Anyhow, he was delighted to hear all about Tony's successes. Well, we also had occasional trips into the mountains there, and I remember after the summer, we went to a quantum liquids meeting at Crystal Mountain near Seattle, though it wasn't called quantum liquids at the time. And there was a cookout high up in the mountains. So Tony first displayed his properties of being a mountain goat. There, we walked together with Chris Pethick, who was also a student of Dr. Haar, who's Tony's advisor, as well as Fred Lamb was also a student. We walked up to the cookout, climbed the mountain. That was fine, it was a very nice cookout. But what I hadn't expected, after dinner, Tony wanted to run down the mountain. So we ran down several thousand feet in about 5 minutes. And the only thing I remember from that was not being able to walk for several days afterwards. But Tony was in great shape all the time. Yeah. Our last hike together was at Lake Diableret about 10 years ago in Switzerland. Yeah. And you just incredibly sprightly going up and down the hills there. So somewhat after Tony's return to Urbana, Blas Cabrera at Stanford had measured the London moment of a rotating superconductor. Piece of niobium. If you rotate a superconductor, it makes a magnetic field inside. That's London's moment there. And so Tony and I and Chris set about trying to explain what was going on, to calculate all this. And unfortunately, at the time, high TC superconductivity was discovered. And so everybody dropped London moments like a super cool hot potato there. And so what happened is that we never published a paper, anything on this. I gave some lectures at Verena where I included the material we had worked on there. Well, actually something similar happened around 1970. In the late 70s, John Bardeen and myself and David Pines were working on dilute solutions of helium-3 and helium-4, which were John Wheatley and Andy Anderson were doing beautiful experiments on the first floor in what used to be a screened room around the corner here. And unfortunately, at some point in just the beginning of the 70s, the superfluidity of helium-3 was discovered. And again, the dilute solutions were just, everybody forgot about that. Tony, fortunately, had the wisdom to realize that this was a wonderful new field, and so we all know the consequences of his switching to that field at the time. What's amusing about that is the dilute solutions are actually coming back and being useful. There's an experiment that Doug Beck and others are going to run at Oak Ridge to measure the electric dipole moment of the neutron, which takes place in a big bucket of helium-3, helium-4. So we've all had to go back and revisit that physics. Now, the spring of 1989 was a big. It was the moment of cold fusion, if you remember that. And it turns out that the only papers Tony and I ever wrote together were on cold fusion, which is very strange. What happened? The cold fusion was what Pons and Fleischmann, Martin Fleischmann, was electrochemist he was a British electrochemist. They somehow in a piece of palladium, which was doped with deuterium, they found extra energy being emitted. And this was attributed to the two deuterium coming together to form an alpha particle, or helium-4. Oh, okay, thank you. I can stand like this? Okay. This is attributed to the two deuterium somehow being helped by the palladium to fuse together to form an alpha particle, a nuclear reaction without, somehow they were magically overcoming the Coulomb barriers, which was pretty silly. Tony had the brilliant idea that if palladium really helps, very strongly favors having helium atoms in it, so that deuterium want to become helium, then you should look and ask, what is the affinity? What is the chemical affinity for helium in palladium? Well, it hadn't been measured, but helium-3 turns out bubbles out of palladium. It just doesn't seem to work. Huh? Is this mic dead? Is this mic dead? Is there a real mic? Is this one working? Now? No. Yes. Wow. Okay. Great. Okay.
So if you want, you can pass it.
Yeah, I know. Yeah. Thank you. Okay. So anyhow, based on this idea that helium does not like to be in palladium, Tony invented a very nice variational calculation that he shared with me. And we wrote two papers, one in Nature and one in Phys Rev Letters, proving that the rate of cold fusion that one could get was a factor 10 to the minus 20, a factor 10 to the 24 smaller than Pons and Fleischmann were claiming. Now, the funny consequence of this, well, we published the only Phys Rev letters ever published on cold fusion. A consequence was that Tony and I, mostly me, became the official referees for cold fusion for Physical Review letters. And these papers would keep showing up, and I would always write back, your letter obviously violates the Leggett-Bain bound, next paper. And they kept streaming it at quite a good speed here. And that was adequate to keep most of the authors at bay. The only exception I remember was Willis Lamb of the Lamb Shift and Bob Parmenter, who would not believe us at all. And we spent hours and hours on the phone trying to convince them, but to no avail here. Another funny consequence is I was invited, and probably Tony was invited as well, to the National Science Foundation, not the physics department, but some deep in electrical engineering. There was a conference being run by the Electric Power Research Institute on the possibilities of cold fusion for the future. And I gave a talk on the work Tony and I did there. And Martin Fleischmann was absolutely entranced. And so he invited me out. Bought me a very nice beer. And the more he heard about what we had done, the more he was convinced that he had done something truly fundamental that could not be explained by ordinary physics. So I actually had the feeling the next day he went out and bought himself a first-class ticket to Stockholm, just to be prepared. Yeah. Well, as I said, that was all we wrote together. Though we've been in very close scientific contact over the years, while we were both interested in cold atoms, my group and his would have a common joint meeting. Or rather, I said we crashed Tony's group meeting. And even though we didn't write papers together, our students have written papers together. Most recently, Zhenhua Yu, my student, and Qizhong Zhang, Tony's student, wrote a paper on the Shinatan's contact and P-wave coupled cold atom systems here. So, well, having Tony as this warm, generous colleague over the year has really made Urbana truly a wonderful place to be. But Tony's always been way ahead of us, which is not simply due to his being smarter, but he's also so energetic and works very, very hard. I remember for several years I lived on Vermont Avenue, where our houses were almost back to back. And so occasionally I would wake up in the middle of the night and peer over and see what was going on in the Leggett house. And if it was after 4 in the morning, the light would be on in Tony's study. And I would go back to bed, but Tony was there working. So, and it's wonderful to see that Tony's boundless enthusiasm and energy continues to this very day. And so, to Tony, let me say happy birthday again, and wish you many, many more wonderful years. Tony. Questions?
Physics questions. So I'd now like to welcome back to Urbana David Campbell, who was our esteemed department head for, 9 years or something? At a very formative time in the department, at least for the exciting times of high TC, I think. David's now at Boston University, but continues to be a great friend of the department and someone who perhaps didn't realize it, but it taught me a lot about how to be department head here. So, David, welcome back.
Thank you, Dale. It's absolutely wonderful to be back here and see so many longtime friends. I don't like to use the phrase old friends because that has another connotation. Not quite as, but if I can just find the HDMI thing, which the guy told me was here, and get into my computer, there, you'll see the reason why I can't simply speak on this. There's some amusing, or at least one amusing picture that we're going to have. Oh, come on. Should have set this up in advance. Okay. Okay. I'll let you guys get that. We'll plug it in. Miracles of technology, please work. Maybe I should refer to the Greek gods. Okay. There we go. Not quite. Not yet. Okay. Well, it really is a pleasure to be back here in Urbana and to hear what I called, when I wrote to our current dean, Bill Showalter, begging for money, the Urbana spirit, the fact that the physics department in Urbana is truly collegial. I also pointed out that it had to be because we were scenically and meteorologically challenged. So it worked. We got some more money, and that's good. Anyway, I won't read this to you, but this is a very selective account of the wonderful years that I overlapped with Tony, 1992 to 2000. And oh, yes, I should point out the title. I didn't give you my title. It's A Brief History of Our Time. And, of course, it's a shameless attempt to get one more reference to time into Stephen Hawking's celebrated title. Nobody gets that? Our? Okay, thank you. Please laugh at the appropriate time. Otherwise, it's very, very depressing for the speaker. So Tony and I have a partially shared background in many ways. We heard quotes from Tony's magnificent bio sketch that he wrote as part of the Nobel. You give a Nobel lecture, but you also write a bio sketch. And if you haven't read that, I highly recommend it. It's extremely witty and very, as one said, humble but witty. Anyway, Tony and I both went through the unimaginable ideal, his words, of the final examinations, he at Oxford for his greats and physics degrees, and me for my Part 3 Cambridge math tripos. And this is probably too hard, too small to read in detail, but the point is, it was an unimaginable ordeal. The last sentence is probably the relevant one. Not surprisingly, the population of psychiatric wards in local hospitals used to peak markedly before and during these periods. It was really stressful. You had no intermediate evaluation. It was all or nothing in 1 week. Pretty bad. I had a similar experience in Cambridge, where I took Part 3, all or nothing exams. You wore your gown to the exam. You were allowed to take it off at the start. And all the papers, you'd get this paper this thick, and there'd be problems from 20 different courses. And you had to hope that you had taken one of those courses, because most of the stuff you simply couldn't understand at all. Unfortunately, one of the people who I took a course from was Jeffrey Goldstone, who taught the quantum mechanics course. His problems always had two ways of solving. One that would take you 3 or 4 hours of tedious slog, and one that required the trick. And if you didn't get the trick, you really couldn't solve the problems. It was annoying to the students that how they got on the exam, because the professors couldn't solve the problems either. But in the room beforehand, when they all vetted the problems, you could hear them say, "Oh yes, Jeffrey, I quite see how to solve that, yes, of course." And none of them could do it. So, unimaginable ordeal. Another part is a shared background, the role that David Pines played in shaping our careers. Again, a long quote from Tony's bio sketch, but the point in the middle here, he found a uniquely posed problem that could be solved only by coming to the group of David Pines and collaborators here in Urbana, and so he applied. Good for students to read on. He didn't bother applying anywhere else, and in fact, it worked out, and he got the job. Similarly for me, I graduated from Cambridge with a PhD in 1970. There were 0 jobs in physics. David Pines as postdocs. David Pines came through Cambridge, and after meeting with me, collaborated together a half-time appointment as an instructor here, but also half-time appointment in the Center for Advanced Study. So we see the circle come around. And one final point, we heard that Tony came back as a postdoc, the return of the prodigal postdocs. After 15 years in Sussex, Tony came back here in '83 with a MacArthur Chair, and after a 17-year career in Los Alamos with much shorter visits, I returned to Urbana as head of the department. So those are our shared background. So briefly, in Urbana, I hit the ground running. I arrived just at the start of the March meeting, unloaded my car, drove off to Indianapolis, and managed to successfully recruit Laura Green and Russ Giannetta, who had been headed to Kent State before we did that. Early in my career, Charlie Slichter gave me some wonderfully sage advice. He said, David, you're the head of the department, you're not the chair. And we don't like to have a lot of unnecessary meetings. What you need to do is to figure out whose ox is going to be gored in any decision, get them all into the room and reach a decision, make it clear and explain to them and go with it. And then he went also on to give me the naval definition of head, and I won't go into that point. Anyway, so what I did when I realized that we needed to have the best people in various positions, I put Tony on the A&P committee. He served for very distinction there. And I was struggling to get my contribution to the MRL's thrust in superconductivity to Don Ginsberg in the time. But here was one of Tony's contributions. Again, this is a little hard to read, but it's worth looking at. This is what the group was going to propose to do in 1993. So Nigel had said something about the effects of the temperature dependence, of a D wave. David had predicted that the theory might be D wave. And these are going to be experiments. They're proposed experiments from Dale and Don and well, not Pines, of course, but theory. But here's the point. The idea suggested by Leggett is to form a DC squid loop connecting the S-wave superconductor between the AC and BC faces of the YBCO crystal. And here it is. Dale had the necessary expertise to do the work, and Don could make the crystals. And here's the result. This is taken from, believe it or not, this is the quality of the government MRL highlights. These are from all the MRL centers. This is taken off of it. The highlight from the University of Illinois was the determination of the pairing state of the high DC superconductors. And I know Dale will tell us a little bit more about that. So unless momentous physical, well, it is physical, but it's not physics. There was an infamous discussion about moving the condensed matter theorists to the ESB, or what was then called CSL, tower. Again, following Charlie's advice, I made Tony the chair of a committee to look into this. Unfortunately, the records of the department are not sufficient to have found the memo, or perhaps, Tony, you only gave me an email or verbal advice. But the committee, in Churchillian terms, we shall fight them at the beaches, we shall fight them in the Kayajos, absolutely refused to do this. And so we'll come back to the end of the story later. So I attempted to move the students to the tower. This was disallowed by Bill Showalter because Joe Green had experiments in the first two floors which had germane and silane, and if they had vented improperly, it could have been bad. So we couldn't put students in the building, but we could put faculty. Anyway, so I moved my research offices to the 6th floor of the ESB with my postdocs and students. We painted them over the weekend. Got a little bit of trouble for that. Unfortunately, I was going to take a picture to show you that, but in fact, it's been changed over to the advanced labs, one of major improvements. So after all the complaints that the condensed matter theorists made about it, they now live in this magnificent building, which if I can get, let's see if I can get this to go. I walked through it yesterday and made a video to prove that well, we'll skip it. The point is you should all walk over there yourselves and see they are very well connected in a beautiful environment. Oops. And definitely 20 years after, so to speak, they made the decision to move. So the other thing we did in the 90s was to totally revise our introductory physics courses. This was a huge effort. Many people involved were here. It took us 3 years. Its origin was in a famous Saturday soccer encounter where the head of TAM came in a soccer uniform, and the heads of all the departments, ECE, physics, chemistry, came in, and they all complained that we weren't teaching them the right physics, and we didn't teach them anything relevant. And in particular, the head of ECE said we didn't teach them anything about the power grid. Well, unfortunately, that was totally false, and I managed to prove that, but we still decided to change things. So this led to really a Herculean effort to change the courses, make them more relevant, bringing in new physics research, physics education research techniques, and it led to the creation of the Urbana group of the Physics Education Research Team, which was awarded the Excellence in Physics Award in 2013. This is all documented in a magnificent article written by Gary Gladding, C. Elliott, and me called Parallel Parking in Aircraft Carrier. Anyway, one of the key things of this was interactive lectures, that you had to have places where the students were supposed to turn to each other and discuss what was going on and provide an answer. Originally, it was done just by raising hands. Now they have fancy eye clickers. So in that spirit, I'm going to challenge this group to tell me which is the healthy heart pattern and what's going on. So let's take a look. How many people think it's A? How many people think it's C? Oh, you're all chicken. Come on, raise your hands. How many people think it's B? And how many people think it's D? Okay. Well, that's heart failure. That's heart failure. This is atrial fibrillations. And this is normal. And very briefly, the reason is your heart has to be able to adapt its ability to respond. It changes dramatically. Just try walking up the stairs and see what happens to your pulse. So that's obvious. But the most important point here is, let's compare this to Tony's handwriting. Truth in physics requires me to tell you that Celia thought of this. She didn't think of exactly this, but she mentioned a comment that led me to it. Anyway, the other thing we did in Urbana in the early 90s, just after I came, was to resurrect the physical review, note how it's spelled. And this revealed amazing talents of our colleagues in skits, stand-up, and song. Wait for the next slide. Let's see, have we got it up there? Right. There was a fake colloquium put on by the students in one of the years, with the students afterwards imitating the way faculty would ask questions at the colloquia. And actually, Tony and Gordon tied as the most often parodied questioners. I wish we had these things recorded because it was really remarkable. They imitate Gordon's like this and Tony's English accent. It was magnificent. But one of the most celebrated scenes was a burger flipping episode put on by the skits, reflecting the seemingly dismal job prospects, shades of 1970, this came home to me. One of the current faculty actually played the leading role as the burger flipper. So the question is, turn to your neighbors, I'll give you some time now, and tell me which one. Now, the wise thing to do would be to look around and see who's red-faced. Come on, who do you think it was? You don't remember? Nobody remembers? It's Peter Abamonte. He was flipping burgers. He was never going to get a job. There was also a lesser-known British rock group that performed. This is in, as you can see, British Thermal Units to the People. There they are. This is performing in the Physical Review, December 1995. Fortunately, we have this picture in color, thanks to Nigel. And so I thought I would give you a brief interlude as an elementary lecture on British historical units, or historical British units. So there are things called a rod, perch, and pole, along with a lot of other non-pronounceable things, that were Anglo-Saxon, 15 Anglo-Saxon feet, each of them, originally. And they were changed between 1266 and 1303 by the, Tony, would you read that for me, please? The Compositio Ulnorum. Thank you. And by the way, so it changed to 16.5 feet. But in a uniquely British way, a perch is not just a unit of length, it's also a unit of area. So it's a square rod. Try working that one out. You know, this is sort of 1 equals 2. With that, you can prove anything in the universe. So this knowledge of Tony's and Nigel's and Paul led to their dirge to the rod, perch, and pole. We don't have a recording of it, fortunately for them. And Nigel did not volunteer to sing it. I guess missing the third member of the trio would probably kill it. In any case, this is the lyrics to the rod, perch, and pole. I'm tempted to indulge myself. Oh, by the way, of course, like most hymns, this dirge has far too many verses. But you'll have to keep a stiff upper lip and bear it as Tony's not amplified, so I'll read it in my, I won't try to fake English accent. Let the candles be lighted, the tocsin be swung, as we wend our sad way to the church. For brethren and sisters, we're here to lament the demise of the rod, pole, or perch. If your homeland is far from Britannia's shore, it will take you a little research to discover what unit of area goes by the name of rod, pole, or perch. Yea, fans of the meter, the hectare, the gram, must think it exceedingly odd that 30.25 square feet is the span that's embraced by the perch, pole, or rod. Yet what friendlier units devised by mankind or played a more practical role than 1 part in a gross of a cricket pitch squared, that's the size of the rod, perch, or pole. But the blighters of Brussels, the bounders of Bonn, our island traditions besmirched, not content with declaring our beer is too weak, they've abolished our rod, pole, or perch. Henceforth, for the bushel, the inch, and the ounce, in Albion vainly you'll search, but the unit whose fate we most bitterly mourn is the ineffable rod, pole, or perch. So, Eduardo, you stole my line. This was the seed of the Brexit movement. And it's also it's song 3.1415 in the UIUC physics hymnal, Sons of the Prophet, words by Sir AJL. But I think actually there's a more appropriate song for this occasion. We could all sing it if we chose. And it's sort of one Nobel Laureate deserves another. So may you build a ladder to the stars, may you climb on every rung, may you stay forever young. So Tony, that's my wish for you on your 80th birthday. Happy birthday and rock on. Sure. Is anyone else going to use these?
Eduardo's going to plug his. So now the dean and provost know where I learned how to be the department head of physics and the way to control things around here. I'd like to now introduce a longtime colleague of the department and of Tony's, and also currently the director of the Institute for Condensed Matter Theory, Eduardo Fradkin.
I always like to joke that that's the view from my backyard. For those that talk about being, how to say, challenged in our views, and someone said something to that effect. Okay, so I was asked to give this talk representing our institute, so we'll try to be as entertaining as I can. It's a very hard act to follow after David's, and I will not have any songs. Okay, so here is, well, happy birthday, Tony. This is a photo I found, I think this probably shortly after you joined the department in '83, doing something to some cat there, okay? All right, so, you know, Tony joined the institute, or the department in 1983, following a long tradition in condensed matter theory going back to 1950s with BCS and the work by David Pines and many others. I only came in 1979 here, so I am a latecomer to that. Tony came in 1983 and already had a huge impact. Actually, David reminded me of something. Tony taught a class, I forgot what class it was, and the students complained that they couldn't understand him, and Tony volunteered to give them some written lecture notes. And then they found out soon enough that he speaks the same way he writes. Okay, so this was followed by the Nobel Prize in 2003, and the group moved to ESB only in 2003 after a generous donor gave enough money to make the tower habitable, because before it was inhabitable, and as probably David recalls, a large group of us actually mounted active resistance against moving to the tower, Tony among them. And our last ditch for not moving was a requirement to have a suitable espresso machine. And this is a bad depiction of that in some movie that some students made for the physical review about that year, I think it was 2003, right? It's not a very nice picture, though, but that's the only one I could find, of the espresso machine. So moving to the tower, or to ESB, after suitably remodeled, changed the way we worked. Okay, so we have large discussion areas, we have lots of blackboards and the espresso machine. And Tony is a permanent presence there. He's usually there. I don't know, maybe he sleeps there, because no matter how early I come, Tony is already there. And he actually talks to the students there, to the visitors. So he's a permanent presence in our institute. Now, ICMT was established eventually. By the time we moved there, it was clear that we were an institute. So it became clearly an institute in 2006, thanks to a grant from the provost, which now needs to be renewed. Sorry, I had to say this. Okay, so let me try to go very quickly through things that Tony did in physics since he came in 1983. It's very hard to cover all of this, and I will just have some highlights, and these are mostly different papers. The first one is the question, is the moon there where nobody looks? I think this was the original title of the paper. It was changed into, is a flux there where nobody looks? There was some question about the physical review not liking the moon in the title. That's one my recollection. Is a paper with Anupam Garg, who was a postdoc at the time. And this actually marked essentially the style of physics that Tony was doing here, foundations of quantum mechanics combined with real experiments or potential experiments that could be done in systems of what nowadays would be called mesoscopic scale systems. Okay. Another direction, which was also part of that, was this monumental paper in Reviews of Modern Physics. I don't know how many thousands of citations this paper already has now. It sort of was an encyclopedic compilation of everything that was new about macroscopic quantum tunneling and quantum coherence at the time. It's a paper of 1987. And it's interesting to see who are the authors, in addition to Tony. Well, Sudeep Chakravarti, I think, was a collaborator. He's at UCLA. Alan Dorsey, who was Tony's student, he's now the Dean of Science, I think, at the University of Georgia in Athens. Matthew Fisher, who we'll see later, is a professor at UCSB. Anupam Garg is nowadays he's in Northwestern, and Willis Berger is at the Technical University in Munich as a professor. So a lot of people that you will see here now actually have come to go to prominent positions. And this paper actually marked an era that there were a lot of several programs, for instance, at the then ITP in Santa Barbara, that followed this paper essentially. So it was an entirely new direction in physics, and Urbana was very much the center of it at the time. Okay, so for example, two of the papers of this type is a paper about this poor cat that Schrödinger had and various cousins, and where he proposed experiments to be done using squids and other devices of the same type. There was a follow-up paper to the famous Caldera-Leggett paper that was written in Sussex, and that was written here, I think, with Amir visiting. I'm not sure whether he visited in '85, I forgot, but he came several times. And okay. He's a professor in Unicamp in Brazil. Okay, so Tony has a long-standing interest in the universal properties of glasses, and this is a paper from the early 90s, where he essentially points out the insufficiency of the popularly used two-level system description of the behavior of glasses and the universal properties. This is still a largely unsolved problem, and there are many people trying to crack it up until today. I think we'll hear Claire probably will talk about that. This is a real hard problem, and it remains unsolved, so far as I know. Okay, so when the high-temperature superconductors came up, Tony had a very decisive and influence on that, and he worked in what I like to call the M word. The M word is mechanism, because when people say mechanism, they begin to fight. So that's why I call it the M word. Tony had a particular view, which I fully share, is that there is in a system which is strongly correlated as this, Coulomb interactions have a huge effect, and usually in the low temperature superconductors, that's a minor effect, but here they have an overriding effect. Tony had this a proposal about where the condensation energy is, and this led to the concept of looking for that in the so-called mid-infrared peak. And we will hear Dirk van der Marel talk about that later in this meeting, about this. And in particular, there is this interesting paper that here, this was 1998, looking at the systematics of the change in the critical temperature as a function of layering, which essentially exemplifies the role of Coulomb interactions in the systems. The other is, it's already been mentioned, it's an experimental paper, but it was a proposal by Tony about how to establish experimentally the pairing symmetry of the high temperature superconductors. This led to this unique collaboration between Tony. So this is actually a rather interesting collaboration, because Dan Ginsberg made the samples, and Dale and his student David Waldman did the experiment. Tony essentially had the concept of what needed to be done. So this is actually very typical of the type of interactions that people have in this department. I have to say, I have not the honor, but the dishonor of being probably one of the few members of our group who has not co-authored the paper with Tony so far, even though we discussed many times. Okay. Okay, so with the advent of the so-called ultra-cold atomic gases, Tony actually devoted a great deal of time to that, in particular to a concept that he had formulated earlier on that now could be established experimentally, which is this crossover between the BCS regime and the BEC regime, Bose-Einstein condensation regime. And this can be done thanks to these so-called Feshbach resonances that essentially allow the system to be tuned between these two different regimes experimentally. And so this led to this rather important paper with his student, Shiyong Zhang. I don't know where he is now. I think at one point he was in Ohio State. He's in Hong Kong now? Okay. Yes. So he was a postdoc, I think, in Ohio State at one point. But, and then there was also the concept of using essentially a partitioned ultra-cold atomic system in a Bose-Einstein condensate regime to actually measure the Josephson effect in that, essentially. This is a paper with Fernando Sols from the Universidad Complutense, who apparently couldn't come if he had other commitments, I was told. I just saw an email from him. He said, yes. Okay, so in Tony's view, and that's my understanding, this discovery of the ultra-cold atomic gases actually offered a unique way to essentially set up a quantum mechanics lab to test actually detailed predictions of quantum mechanics, which are very hard to actually control in other macroscopic systems. These systems are uniquely isolated, and therefore they can be controlled to a greater degree than, say, in a solid-state regime. And in particular, here is a proposal with Masahito Ueda, who is now, I think, at the University of Tokyo, if I am. Is he here? I think he's here. Okay, there you are. Okay, good to see you again. So in particular about testing the ideas of macroscopic quantum tunneling in a Bose-Einstein condensate. Okay. This is from the late 90s. Well, as you know, if you're not topological, you're nobody these days. And Tony decided to take an interest in that. This actually was partly the first paper, was on our putative candidate for a topological superconductor, which is strontium ruthenate 214. Whether it's topological or not is still an open question. There was this beautiful experiment that was done here by Rafi Budekian, who unfortunately decided to go to colder climates. Rafi did this nice experiment on a ring made of strontium ruthenate, and in suitable conditions, he saw evidence for a half-quantum vortex. And this was debated in the literature about whether this experiment could be reproduced, which now many of the people who disagreed have now reproduced it. And Tony wrote a paper with his student, Victor Vakariuk, who's now on the editorial board of Physical Review Z, X, Y, Z, I forgot. Okay, so if you have any complaints about refereeing, you know who to talk to. Okay. So they wrote actually a beautiful paper explaining how this half-quantum vortex arises associated with spin polarization of the state. And in particular, I've been fond of a paper with Sankit Yeb, who was a student in the early 80s, or mid-80s, on the motion of the AB interface in helium-3. That paper, I think, has the first prediction of, I guess one would call a Majorana current. So there are neutral quasi-particles that apparently move at right angles as this wall moved. That's what I recall. I remember being at the thesis defense at the time of Sankit, and this was actually quite a prediction. He's now in Taiwan, I think. Yes. Yes. So this is actually predates many of these things, okay? But in fact, to this day, people have been trying to find the evidence of Majorana edge states and currents, and this is probably one. The experiment was supposed to be done by John Wheatley, but John Wheatley passed away shortly after that, after the time of that paper, I think. So this experiment has not been done, so far as I know. It has been? I see, okay. Okay, something is happening here. Okay, there we go. Oops. All right, so in this age of Majorana, Tony, we discovered or rediscovered another streak of Tony, which is his role as an independent thinker and his penchant for being a contrarian to what everybody else thinks. And everybody decided that we may have evidence for these Majoranas that may be non-abelian quasi-particles. Tony has been complaining from day one that this is all done at the level of the BDG equation that fixes the phase, and therefore it doesn't preserve the number of particles. And so here is a paper he wrote quite well. The paper came late, but he's been talking about this for quite some time. And actually only last month there was a paper with his former student, Eurolin, where essentially he had to say, lays the gauntlet to people about how to interpret this type of experiments. And this is actually a problem of great importance for our understanding of the potential of these ideas for quantum computation. So let me finish by saying congratulations, Tonys, and thank you for all the great physics and the friendship.
So I think Tony's impact on theory is well known, but I would argue his impact on experiment is equally as strong. Tony's been one of the, I think, main people in our department who has always paid attention to samples, paid attention to what can actually be measured and what can't, and has been a real inspiration for the experimentalists. So I'd like to invite an experimentalist, Ralph Simmons. Ralph, to come forward. And Ralph was department head when I came, and he hired me, and that was good, for me at least. But he hired Tony, he hired Eduardo as well, and he hired Tony, and that was good for all of us. So, welcome. Look into this if you'd like, or use the, oh, maybe not.
For some reason, these always seem too low.
Yeah.
Does that work? Can you hear me? You're about to hear a voice from the past. I came to Urbana in 1952 as a graduate student. I never expected to stay. I did hope to get a degree. I had just survived exams at Oxford, just like were described. I'm afraid I didn't take them very seriously, but they did pass me at least. When I came here, it was nice, and now I'll get back to that. Thank you so much, Fred. I dried out. Now I can speak. I welcome all the friends and admirers of Tony. I'd like to mention an incident from 30 years ago, 1988. Several years before that, we'd had a terrific birthday party for John Bardeen. And then he got wind that we were planning another one. And one day in my office, here showed up John with daughter Betsy. I knew I was in trouble because John, always soft-spoken, first words were, "I do not want another birthday party." And Betsy behind him was saying, "He really means it." Well, we found another strategy, and the result was an event called New Horizons in Physics, looking forward. So, 30 years later, we're having another event of that kind, looking forward, and that's a tradition now in the department that John, in a way, started, and with Tony, we can continue. I'd like to take you back even farther. I'd like to talk about the origins of this department's mix of excellence and collegiality. It can be attributed to head Wheeler Loomis, whose name is attached to this building. It's a tradition of a first-rate department whose members see themselves as part of a community, not a collection of independent fiefdoms. Also, new arrivals are welcomed, no matter how young they are, and made to feel full members of this community. Wheeler Loomis came in 1930, which was not a good time because financial depression was spreading everywhere. And Wheeler was quite constricted in his hiring. But by 1938, another 8, he was able to make some hires. 2 of those hires were youngsters named Don Kirst and Bob Serber. Kirst had an idea about an induction accelerator that could produce high-energy photons. But there was a problem of stability of the orbits. Bob Serber, who had no particular knowledge or whatever about orbits or accelerators, was trained as a general theorist, pitched in and helped Don Kirst solve this problem of stability. That's typical, that no one feels that they have particular turf to work in, but they have a feeling of cooperation. Another thing happened in 1938, by the way. Tony was born. And that was also very significant to the department. By the 1950s, the big Betatron was running, and the whole campus knew when it was running. It had been built out by the university power plant because it was a big hog of electricity. But it was a gigantic resonator which fluttered all the campus lights at its resonant frequency, which was 6 hertz. So everyone all over the campus knew when the Betatron was running. This was a bad influence that physics had on the rest of the university. We hope that it's been a better influence ever since. By the 1950s, after the interruptions of war, the big Betatron was in operation at energies above the pion threshold for photo production. There wasn't all that much known at that time about photo production processes. We had a couple of young faculty members, name of Francis Lowe and Jeff Chu. They had an office together in the old building. They were a strongly interacting pair. Everybody knew that because of the noise coming from their office about their discussions. Those discussions became the butt of physics graduate student skits that you've already heard about. But they were cheerful about it. And other cooperations around the Betatron helped this department tradition grow. Ned Goldwasser and his wife, Lizzie, a most loyal member of the department still. Ned Goldwasser and Gilberto Bernardini worked together, not as competitors for the Betatron, but in planning an experimental program. Department theory students, you should know, at that time, had very poor space to work in. The old physics building had 3 floors and an attic, and what would have been a basement, except it was a swamp flooded by the boneyard. Between the 2nd and 3rd floors, there was another floor inserted, an interstitial floor, and the graduate students in theory lived in this cubbyhole. They called it the Institute for Retarded Physics and ventured out from time to time, and including those times that they presented hilarious skits for the department. In addition, there were postdocs. They had somewhat better circumstances. Summer postdocs included people like T.D. Lee, Murray Gell-Mann, Frank Yang. Leon Cooper had a little better space. He shared his office with John Bardeen. And whenever anyone later among the postdocs came to me complaining about office space, I reminded them of the benefits of sharing an office with a faculty member that Leon Cooper had had. And they came to accept that. They didn't like it, but they came to accept that. Now, speaking of cooperation, and mentioning several of the names I did already, there was a beautiful work early on written by T.D. Lee, Francis Lowe, and David Pines, all working in different areas, but it was on the subject of polarons. So solid-state physics at that time had become a respectable part of the department to join those people who had been the best part before, namely the nuclear folks. Frederick Seitz had helped establish all that with Bob Maurer and Charles Wirt of Metallurgy. Materials Research Laboratory was born and built in the 60s. But physics has never been totally jealous of its territory. It has fostered spin-offs beginning in the 50s. One was the DCL, the Digital Computing Lab, which has now morphed into a department, plus CSL, which has become an important, strong interdisciplinary lab. Each of those had decades of physics faculty directorships, but have been cheerfully spun off for the great benefit of science, technology, and the university. And I'll stop bragging after this. Physics has also helped launch startups such as nuclear engineering, the National Center for Supercomputing Operations, and the Beckman Institute. Back to cooperation again, briefly. In 1967, Leo Kadanoff led a series of seminars participated in by graduate students from various areas within the department. The subject was data and interpretation of scaling near critical points. The result was a publication in Reviews of Modern Physics by Leo, but as co-authors, full co-authors, those 9 graduate students from different areas of the department. And that was an important publication in the Reviews of Modern Physics. I'm so happy as I look around to see those people who had come to work with Tony and others, for example, Claire. It's wonderful to see you again. These things we are going to hear in the next day and a half or 2, honoring Tony, are just a small, but we hope important thing that you can remember for all, and thanks for all the things that you've done for us, and thanks for the things that you've done for the world of investigation. And finally, the totally humane way you have done it. It's wonderful. Thank you. I also hired Eduardo and Nigel and Dale. Anyway.
Thank you.
And thank you, Timur, for your history. It was wonderful to hear that. Sorry about the bragging. You've heard me before about that.
So I don't see Miles. Miles, are you here? Pardon? Oh.
Thank you. I didn't mean to steal.
No, that's okay. It happens all the time. So I don't see Miles Klein, but I would like to now introduce someone who is a longtime colleague of ours at the University of Illinois and worked very closely with myself and Tony and everyone, Myron Salomon, who was here for a long time and then dean at UT Dallas, and now is retired and having fun in Santa Fe. So Myron, welcome.
Thank you, Dale. Thanks very much. I had dinner with Miles last night, and because tonight is the first night of Passover, he was going up to Chicago to have Seder with his daughter, Cindy, so he's not here this morning. All of you have heard about the history of Tony coming to Urbana, and all of us were delighted to have him come here. He played an important role in the development of superconductivity effort here. I was head of the MRL, and we had already gotten some new money from the Science Foundation to start superconductivity. And Miles played an important role in putting together a center for superconductivity. It's called the STCS, which was joint with the University of Chicago, Northwestern University, and Oregon. And I remember very clearly about going up for many, many meetings in Chicago where we fought with the people at at the other institutions about whether the superconductivity of high TC superconductors was D wave or S wave. And my wife often asked me, how did you put up with all those boring rides up to Chicago and all those fights? And I said, well, Tony was there, and he backed me up because I was a strong proponent of D wave superconductivity. And I also often told her I got a CPU time, chance to talk to Tony for 2 hours while we were driving. Out of that came a joint paper. Just before Dale's paper, Tony and I collaborated on a paper on the thermal conductivity of D-wave superconductors. And you heard a little bit on the paper about Andreev scattering, and I had come to the idea that what we were seeing was the D-wave scattering of quasi-particles from vortex lines, and that was the first evidence that we thought we had for D-wave superconductivity. All along, while we were here, we knew Tony was going to get a Nobel Prize for his work on superfluid helium, but we were disappointed. He wasn't disappointed, I don't think, or at least he never said so, that the prize for helium-3 went to 3 people from Cornell, and said, well, sic transit gloria, I guess. But in 2003, the mistake was corrected, and Tony was one of 3 people who got the Nobel Prize, he, along with very illustrious other people, Abrikosov and it's written down here somewhere. Anyway, we lived in the same block as Tony. The block of Pennsylvania Avenue near Busey was the home of about a third of the physics department. And my son, who's a WAG, when the Nobel Prize was announced in 2003, sent me an immediate email, and he said, be the first on your block to win the Nobel Prize. Oops, too late. Right after that was announced, there was a reception here. It happened that year that Paul Lauterberg was awarded the Nobel Prize in Medicine. So there were 2 Nobel Prizes here at Urbana the same year, and there was a big reception at the Atlanta Union for the Nobel Prize winners. And so I was invited. And I came in, and there was Tony, dressed in a suit and tie, surrounded by a lot of people. I'm just kidding. He was in his usual nylon windbreaker, sitting all by himself. And so the people from the public relations office came up to me and said, would you go over and sit beside Professor Leggett so that he's not all by himself? And I guess that broke the ice. When I think about today's celebration, I went to look at Google and see what we find about Tony Leggett. So I just put in Leggett, no Tony Leggett. What comes up is a town in California that's called Leggett, a manufacturing company called Leggett and Platt, a company that sells trapping supplies in Missouri, no Tony Leggett. So of course I said, okay, I better put in Tony Leggett. So I did that, and up comes the Wikipedia, which is nice Wikipedia article, a little announcement from the physics department. And then there's another Tony Leggett who gives psychic advice for the magazine National Examiner. So I'm not sure whether Tony Leggett is moonlighting, psychic. But one thing for sure, and I think what's been clear here from everything that's been said, is that he may not be a psychic, but he certainly is in touch with the cosmos. So happy birthday, Tony.
Thank you, Myron. So we're going to stop in just a minute, but you'll notice I did put myself on this list to talk about experiments, and I did that because I think there's no one in this department who has benefited more than Tony being here than me, because as I have said to many people, Tony came here in 1983. I came in 1981, so it's pretty clear to me that Tony came here to work with me. Now, maybe that's not really true, but I'm going to go with that because it's a good story. But I certainly benefited from him being here. My first experiment was on 2-level systems. I learned from him. My second experiments were an MQT that people talked about. And the one that I think I'm most known for or had the most impact on was the D-wave controversy. And people have talked about that. And I think the interesting thing, as Eduardo pointed out about that, is it really does exemplify what we now call the Urbana style. David called the Urbana spirit, which is experimentalists working with theorists in teams. And I think that one of the sad things about, this is a very happy occasion, but one of the sad things is we're happy for all the people who could come, but we're sad for some people who could not be here. And I think if you look at that problem, there are a number of people who are not here who had a big impact in that problem. And it started out as a controversy in some sense between Phil Anderson and David Pines over whether it was S-wave or D-wave. Phil we invited, he could not come due to medical reasons, but did send his birthday regards. David Pines is back in town, but he is not very well, and so we invited him to come. We're hoping he may show up sometime during this session. He has an office over in ICMT, but he was not able to come. And as I think you know, the motivation for David's model was Charlie Schlichter's work, and I think Charlie, as all of you know, passed away a couple of weeks ago, and there will be a memorial next Saturday for Charlie. The other person that was very key in that experiment was Don Ginsberg, who made the samples. None of this would have happened with all of these people, and Don, of course, passed away a decade or so ago. And so as we celebrate Tony's life and career, it's hard not to think about those people who I had hoped would be standing here and talking to you at this time. So I just wanted to bring that up. That was a really great problem to work on, I think, in Urbana. Of course, it was good for my career, but it was just really great fun, and I think as much as any project I've been on exemplifies how we work in this department, how the whole community pulls together to do great things. And the heart of that experiment was Tony's idea, and I can never be more grateful for what he did for my career. So we're going to stop now, and we're going to take a break for 30 minutes or so, or 25 minutes, lots of food, lots of things. Thank you to all the speakers. It's been really fun to hear about this. Thank you.